In this circuit, we have a battery, 50 ohm resistor, 100 ohm resistor, and a 10 millihenry inductor. Part A, what's the current in the 100 ohm when the switch is, part 1, just closed. When the switch is just closed, the inductor behaves as an open switch. So the circuit is gonna look like that. The battery, the 50 ohm resistor, the 100 ohm, and the inductor, which no need to draw it because again it will behave as an open switch. So the current in the circuit, I, will be V over R using Ohm's law. V is 15 and R, it's the R equivalent. 50 and 100 are in series, so you add them and you will get 0.1 amperes. 0.1 amperes. 2, closed for a long time. For a long time the inductor will behave as a wire. So the circuit will look like that. The battery, the 50 ohm resistor. Now the 100 ohm is parallel with the inductor, which behaves as a wire. And whenever you have a resistor in parallel with the wire, no current is going to pass through that resistor. The current will pass through the wire. This means the current in the resistor is 0. In the 100 ohm resistor, the current is going to be 0 because again it's parallel with the wire, which means no need to draw the 100 ohm. Part B, find the rate of change of current in the inductor when the switch is just closed. This is the circuit when the switch is just closed. So let's redraw it again. You have the battery, the resistor, the other resistor, and the inductor, which is again an open switch at time equals 0. This means that the inductor is parallel to the 100 ohms, so they have same voltage. So voltage of the inductor is the same as the voltage of the 100 ohms. Using Ohm's law, it's Ri. So it's 100 multiplied by the current, which is 0.1. Found it here. So the voltage will be 10 volts. Now, how do we find the rate of change of current? The rate of change of current, using the formula for the voltage of the inductor. V of the inductor, it's L di by dt. Then di by dt is V over L. This is how we find the rate of change of current in the inductor. So V over L, the voltage of the inductor, we already found it 10 volts. And the inductor is 10 millihenry. So it's 10 times 10 negative 3. So the answer is going to be 1000 unit is amperes per second because it's di by dt, it's current over time.